Very good afternoon, students. Welcome to the SBR online Rich Course classes. So, we are dealing with the logarithm concept, students. So, in the previous three lectures, we come across the definition and properties of logarithms. Now, let me discuss about how to find the logarithm of a value with the base 10 and that finding mantissa as well as characteristics here, right? So let us learn some of the concept here, that is characteristics and mantissa of the logarithm, right? Now you see, students, so studying this characteristic and mantissa, so it is based for only common logarithms, right? Common logarithms, I told you that. So logarithm of a value with the base 10, right? Logarithm of a value with the base 10 are known to be what here? Common logarithms, right? So uh, characteristics and mantissa can be found with the with what here? What type of logarithms? With the only common logarithms. Got it? Whose base whose base is what here? 10. Okay. So here will be the numerical value. I told you logarithm of numerical value they will be providing. Numbers they will be providing it in the form of numbers. If there are variables, the base will be what here? E, known to be natural logarithm. Here base is 10. Why? Because log of the numbers we are finding here. So now, got it? So these two things are applicable for what here? Common logarithms. Right? These two concepts are discussed for only common logarithms. Now, so how to find characteristic and mantissa part for the logarithm of a number here, of the base 10. So just see, students, if I mention like this, 1, 2, 3, 4, if I mention like this, students, you should think that the base is always 10 here, log of a number here. Right? If I have not mentioned the base 10 means it is understood. The base is always what here? 10. If I do not mention this, it is understood that base is 10. Got it? So that is a common logarithm, right? Now let us discuss here. Right? So as we said about the definition here, exponential form, a raised to x is equal to b, then x is nothing but what here? Logarithm of b to the base a, where a should be positive real number other than 1, and b also should be positive. A should be positive other than 1, and also b should be positive. Now, how to find the value of logarithm of b to the base 10 now, common logarithm, right? What will be the value here? Let us find out. So now you see, logarithm of b is a number here, always the base will be 10 to find out characteristic part and mantissa part. Now you see, here of course the b value will be positive then. Of course b value they'll be providing. Log of positive numbers only you can find. Log of negative numbers you can't find, right? So it is not defined there, right? If you substitute the and also a is positive means if exponential thing what you give always positive you are getting there. So logarithm is defined for what here? Logarithm of positive numbers only it is defined there, right? Only positive numbers you can give the input of logarithm. Okay. So now if they have provided logarithm of a number, they have provided logarithm of a number, how to do it? I'll be telling you later. First you see, logarithm of a number, right, will be obtaining at last here. The output of this thing will be in the form of two parts here, right? Logarithm of a number will be having in the form of two parts here. So one is of integral part, we say integral, integral part, and decimal part or fractional part. Logarithm of number will be obtained in the form of two things there. By integral part, one is integral part, another one is fractional part, right? So something, if logarithm of a number you are getting like this, something here, right? Like this if you are getting, so 3.1343 if you are getting means, so before the decimal point we say it as integral part, students. So this is the integral part. after the decimal point, we say it as decimal part here or fractional part we say. So this integral part is nothing but what here characteristic we say here. So this integral part of log value, right? Integral part of log value is nothing but what here characteristic part, and decimal part of the log answer here, right? Will be what here Mantissa part we say, right? What we say here, decimal part or fractional part we say it as Mantissa, and the integral part we say it as characteristic. Got it? Suppose if you got like this here, uh, log 2, and if you are getting like this 3010 in this form, right? Suppose log 2 you are getting it as like this, right? 3010, right? So here 0 is nothing but what here characteristic part. Here this is nothing but what here Mantissa part. The numbers after the decimal point, the numbers after the decimal point are known to be what here Mantissa part, and number before the decimal point, this is known to be what here integral part. Integral part is nothing but what here characteristic. Got it? So log 2 answer is what here 0.3010. So 0 is the characteristic part, characteristic number here, and 3010 is a Mantissa number. Got it? So how to find all these things? So we have the procedure, students, how to find the characteristic part of a logarithm value and how to find the Mantissa part of the logarithm value. We have a particular procedure. So let me explain you about the procedure, students. Okay, just pardon me. One second. Got it now? So how to find characteristic part and Mantissa part? Let me explain you. Suppose if I have, first let me explain about how to find characteristic part. Right? Finding characteristic part. Just here. If I have like this logarithm of, right, 1, 2, 3, 4, right, logarithm of 123.4, logarithm of 12.34, logarithm of, right? Now you see, I want the log value of these things, students. I want the log value of these things, that too only characteristic part. I told you integral part is nothing but what here characteristic part. I'm dealing with only characteristic part now, and how to find Mantissa part I'll be explaining you later then. So now let us find out first how to find characteristic part, students. If they have given log of the values here, numbers, of course the base will be 10. I told you earlier itself. Of course the base will be 10. We are dealing with only common logarithms. So now, and also students, log the value should be what here 4 thing. Log input should be what here 4-digit numbers. It takes what here only 4-digit numbers it take. It won't take more than 4 digits. But characteristic part can be found with any number of in digits of the inputs of log there, right? Now we see, students, right? Characteristic part, just here. How many digits are there, students? How many digits are there? Log of how many digit number it is? 4-digit number. 1, 2, 3, 4. Right? It's a 4-digit number. Then characteristic part will be, the characteristic part will be 3. There are 4-digit numbers, means subtract 1. 4-digit minus 1. What happens? 3-digit. Right? That is 3 will be the characteristic part. How do we get this? I'll be telling you later then. Now you see. Go for the second one here. 123.4, log of 123.4. 123.4. It's a how many digit number it is, students? 123.4. 123, you have to consider only this one. You have to consider only this one, students. 123 only you have to consider. Leave the decimal part for the characteristic part, what you want to get here. See here, 123 is only 3-digit number. Previously 1234, it was 4-digit. We have written 3. Now it is what here? 123. It is a 3-digit number. 3-digit number subtract 1 now. 3-digit number subtract 1, what do you get? 2. 2 is a logarithmic characteristic part of this answer or log value here. Now you see, go for this one, students. 12.34. Now it is how many digit number it is, students, here? 12. 12 is how many digit number? It is a 2-digit number, students. 2-digit number minus 1, you do it. How much you will getting? 1. 1 is the characteristic part, right? Now you see, go for the next one here. 1.3234. So it is a how many digit number, students? Only 1-digit number. 1-digit number it is. So 1-digit number minus 1, you do it. What do you get? 0. 0 is the characteristic part, right? So Mantissa part I'll be telling you later. So this is what your characteristic part of these log answers here. So how do I obtain this 3 here? If it is a 4-digit, how do I obtain 3? If it is 3-digit, how do I obtain characteristic part as 2? If it is 2-digit number, how do I obtain characteristic part as 1? Similarly, if it is 1-digit number, how do I obtain characteristic part as 0 then? So there is a simple way, students. Just here, we have to go with this number here, 1, 2, 3, 4. We are dealing with the base 10, right? Base 10. So in the school level, you have studied about this one here. How do you express 1234, students? How do you are expressing that one here? You are expressing in this way. 1 into 3 digits are there. Means 1 into 1000 plus 2 into 100 plus 3 into 10 plus 4. You are writing like this. Yes or no? So now you see, right? Now you see. So in this manner, you are expanding in the school level. That now you see what we are dealing with the base 10 common logarithms, right? We have to go for the base thing here. So that too, what is the definition of logarithm, students? If the exponential form is like this, so this exponent itself is what here? Logarithm value. This exponent itself is what here? Logarithm value. We told in the definition of logarithm. Now we see we are dealing with a 4-digit number now. That is 1, 2, 3, 4. See the 4-digit. It is in the place of units, tens, hundreds, and thousands place. Yes or no? Correct. So see the units place. How do you express units place, students? 10 raised to 0. That is 1. 10 raised to 0 is 1. Agree. 10 raised to 0 is 1. 4 into 1 you are saying there. That is 10 raised to 0. 10 raised to 0 is 1. 4 into 1 you are saying there. Got it? Right. Next will be your tens place. Tens place means how do you express? You will be expressing in this form here. 10 raised to 1, students. 10 raised to 1 is 10. Hundreds place, how do you expressing here? 2 into 100. Hundreds place, how do you expressing? Hundreds place you are expressing in this way here. 10 square. 10 square, right? Whereas this 1 here, students, the first significant figure we should take here. So what is the first significant figure in this here? 1. So see in what position it is having here. 10 to the power 4, right? 10 to the power 4. Here base is 10. We are dealing with the common logarithms base 10. So the exponent itself is log value, I told you by the definition. So what is the power of this one here? Sorry, it's a 10 to the power 3, student. Sorry. Okay, no problem. So this is 10 raised to 0, 10 raised to 1, 10 raised to 2. What about this, students? Sorry. What about this? It's a 10 to the power 3, 10 to the power 3, right? So 1 into 10 to the power 1 into 1000 you are writing. That is 10 raised to 3. You can express it. So the power itself is nothing but what a log value we told in the definition. So we have to go for the first significant figure of this logarithm value. The first significant figure is what here? 1. So we have to look at the exponent of this one here. What it is in the position of what here? 3 there. So that's why we take the characteristic part as what here? 3, students. Got it? So the power of this base 10. What is the power of this base 10 now? 3 for the first significant figure of 1, 2, 3, 4, right? That is 3. The power is 3. That's why we write the characteristic part as 3, students. If it is a 4-digit number, the characteristic will be what here? 3. So this is the reason, right? So now let me go with the next one here. Let me go with the next one, students. That is 123.4. So what will be the characteristic part? Let us look it out here. So before the decimal point, what do you express this position now? It's a unit, tens, 100, right? So this position, how do you express? Like this, 10 raised to 0 form. And how do you express this, students? 10 raised to 1 form. And how do you express this? 10 raised to 2 form. So this is the first significant figure. We have to approach with the first significant figure, students, here. 1 is the first significant figure from here. So now we have to look the exponent part. Base is 10. We have to look at the exponent part. I have to choose only the exponent part here. By the definition, x itself is log of the answer, log of b to the base e. Right? X value will be the log of the answer. So the power is what now for the first significant figure here? 2. So that is the characteristic part will be the 2. Got it? If it is of 3-digit number, if it is of 3-digit number, 123 is a 3-digit number. What do you get the characteristic part here? The power will be what now? 2. So this is the reason, students. In the same sense, 12.34. How many digit number it is? We have to look only the integral part here. That is 2-digit number here. 2-digit number, right? It's a 2-digit number. The 2 position is of what here? 10 raised to 0. Next, here what here? 10 raised to 1. Got it? So the first significant digit is what here? 1. So its exponent form of the position we have to see here. That is 1 is the exponent form. So if it is of 2-digit, so the characteristic part will be what here? 1. Got it? Now go for this one here. Go for this one, students. 1.234. We should not look after the decimal numbers here, right? So for the characteristic part, we have to see how many digit number it is. It's a 1-digit number. 1 point something means if you round off all the things, you will be getting only 1-digit number there, right? So 1-digit number you're getting. The 1 is the first significant figure here. So it is in the position of what here? 10 raised to 0. The base is 10, common logarithm. And the exponent itself is nothing but what here? Log value. So it's a 1-digit number. The characteristic part will be what here? The exponent of this one here. That is 0. If it's a 1-digit number, it will be what here? 0, right? So now 5.383. It is also what now? It's a 1-digit number. 5.383. If you round up all the things here, 1-digit number it will be getting. So it is again, it is in the position of what here? 10 raised to 0 there. So 0, 1-digit number means characteristic part will be what here? 0, 1 digit. So we have the common format here. So if the number of digits, logarithm of digits are k, then characteristic part will be k minus 1. Then characteristic part will be what here? K minus log of k numbers you have. Log of k digit numbers if you have. K number of digits if you have, log of k number of digits, then characteristic part will be out here. Only characteristic part, students, only characteristic part I'm dealing here. Characteristic part will be k minus 1, right? Got it? If you have log of 10 digits, what will be the thing here, students? Tell me. Anybody? So what happens here? Log of 1, 2, 3, 4, 5, 6, 7, 8, 9. If we have 9-digit number, log of 9-digit number if we have means, so then what will be the characteristic part, students? The integral part of log value, log answer is characteristic part I told you. So what will be the characteristic part? 9 digits are there. So subtract 1. 9 digits minus 1. What happens? 8. The characteristic part will be what here? 8. Got it? Understood this? Right? Now, so this is the case, right? So now you can say the things here. Now you can say the things about the characteristic part of a logarithm. Now you see, students, log of the numbers from 1 to 9, 1, 2, 3, right? All these things. 1, 2, 3, 4, 5, so on up to 9. All these are what here? One digit number. 1, 2, 3, 4, 5, 6, 7, 8, 9. All are what here? One digit number. Now you see 10, 11, 12, 13, so on up to 99. All are what here? Two digit numbers. Yes or no? Now go for this one here. 100, 101, 102, so on up to 999. All are what here? Three digit numbers. Next, students, 1000, 1001, 1002. All are what here? 9999. And so on here. Right? Now you see. So log of single digit numbers, log of one digit numbers, log of one digit numbers are there. Right? Then characteristic part will be what, students? Characteristic part will be 0, right? The number of digits are k, means characteristics part will be what here? K minus 1. I told you. Got it? Why? I told the reason there, right? Because it's in the form of 10 raised to, it is in the position of what here? Unit place. Unit place can be expressed as 10 raised to 0 there, right? So now it is what now? It is what here, students? It is a 2-digit number, right? It's a 2-digit number, right? So what you have to do? The characteristic part will be 1, 2-digit minus 1. 2-digit number minus 1. 2 minus 1, how much? 1 there. Got it? Now all these things are what here? 100, 101, 102, so on up to 999. All are 3-digit numbers. So what will be the, these are the 3-digit numbers, right? What will be the characteristic part, students? 2. Subtract 1. Here all the things are, all are what here? 4-digit numbers. 4-digit numbers, right? Then characteristic part is how much here? 3. If I have 100-digit number or 1000-digit number, if I say, right, log of 1000-digit number, what will be the characteristic, students? That is 999. 1 you have to subtract from the number of digits. Got it? Understood? So this is one of the things here, right? Log of these things. So this is one of the case to find out the logarithm of a number, right? That to finding the characteristic part of a logarithm, right? So now you see, if you have like this, students, if you have like this, log of 0.1234, log of, right, 0.01234, log of 0.01234. Let me take some extra things here. One, or let me take like this, right? If it is of like this, then what will be the characteristic part, students? Same thing, characteristic part, right? So firstly, what I said, log of numbers are the log of values they have given, number of digits. We have to subtract 1, but there is no digits here. How many digit value it is? No digit it will be saying there, right? If you say 12.334, it's a 2-digit number you are saying. After rounding off all the things, you will be saying it's a 2-digit number, sir, you are saying. So then how many digit number you will be saying there? 0 point something, right? So if there are no digits here, if they are giving only 0 there, then what to do? Just see here. Then what will be the characteristic part? Then what will be the characteristic part if this is the situation, right? So now we see here, we have to see the first significant figure after the decimal place here. After the decimal point, find out the position of first significant figure. First significant figure means non-zero number. You should see after the decimal point. See, after the decimal point, the first significant figure is what here? 1 itself. Non-zero quantity. The first one non-zero quantity is what here? 1 itself. Right? So the position of the position of first significant figure is 1 itself, right? So what we have to write, we have to express negative there, we have to move in the negative sense, right? So that is a minus, we have to write -1 there, right? Got it? After the decimal place, go for the non-zero quantity, first non-zero quantity, right? So in which position it is there? It is in the first position. So write on 1 there, that too in the negative sense. Actually, the answers, we should not mention the -1 there. Instead of writing -1, we express 1 bar, students. We express what here? 1 bar. Instead of writing -1, we express 1 bar. Now you see, students, go for the second one here. After, if there is a no number here, if there are no digits here, right, only zeros they have given, 0 point in the form of the numbers, they are lying in the form of like this, log answers, log numbers lying from 0 to 1 there, right? So means you can't say it's a 1-digit number, 2-digit number, you can't say anything, all are 0-digit numbers. Now what to do for the finding characteristic part? Go for the first non-zero quantity, go for the position of first non-zero quantity after the decimal point. Here after the decimal point, it is a zero quantity, leave it. Now next what we have, it's a non-zero quantity, first significant figure after the decimal point. The position, see the position here, in which position you have here after the decimal point, one first position and second position. In the second position you have the non-zero quantity. So you should check the position of first non-zero quantity after the decimal place if they have given 0 digits here. So in which position we have? 2 position. So that is, you should mention 2 bar, 2 bar. So why we should write like this, I will be telling you later there. Now go for the next problem, students here. Next log of this value here. So now, of course, 0 point they have given means it's a no digit number here. 0-digit number it is, right? You can't say it's a 1-digit number, 3-digit number there. So what to do for that one to find the characteristic part? Go for the position of non-zero quantity after the decimal point, after the decimal point. So in the first position, you won't get the, you are not having the non-zero quantity. In the second position also, you are not getting the non-zero quantity. In the third position, you see, that is 1. In the third position, you are getting non-zero quantity. In which position you are getting the non-zero quantity? Third position after the decimal point, after the decimal. So what you should mention here? Third position you are getting the non-zero quantity. So you should mention 3 bar. Actually, it will be -3. We should not write -3 there. Instead of writing -3, we should express 3 bar, right? So now you see, for the students, tell me the position of this non-zero quantity after the decimal point if they have given the 0-digit number, right? 0-digit number. So after the decimal point, right, first the position of first significant figure. In the first position, it is not, no, it is not a non-zero quantity. It is a 0 here. No, not possible. Third position also, there is no non-zero quantity. In fourth position also, there is no non-zero quantity, right? In fifth position also, there is no non-zero quantity. And in the sixth position, if you see, first position, second, third, fourth, fifth, and in the sixth position after the decimal point, the first significant figure you are finding here. So in sixth position you are finding no. So the characteristic part will be 6 bar, students. You should write actually -6 there. So -6 we won't express here. We, instead of expressing -6, we express 6 bar here, logarithm. So characteristic, after finding all these things, you can say that characteristic part may be positive, may be negative, it may be 0 also, right? So in the previous thing, right? Sorry. Okay. So you can see that in the previous things what we did there, the 4-digit number, the characteristic part is 3, right? If it is of single-digit number, the characteristic part is what here? 1 minus 1, 0. So you may get positive characteristic part, you may get 0 characteristic part, you may get negative characteristic part like this. Got it? So characteristic part may be what here? Positive or negative, or it may be 0 also there. Got it? So, and now you see, so how do you have written this 1 bar, -1, -2, -3, -6? How do you have written this, right? So in what sense you have writing this characteristic part for this logarithm value? So let me explain here. So now you the same school level form students here. It is a 6 bar we got here. So now go for the first point, first logarithm value here, right? So if it is like this, students, 123.4, here you are saying 10 raised to 0 before the decimal point, 10 raised to 0, the units place, tens place, how do you express 10 raised to 1, and hundreds place you are expressing 10 square there. So where after the decimal point, you see, students, after the decimal point, how do you express this? You are expressing in this way, students, 10 to the power minus 1 after the decimal point. After the decimal point in the position, how do you expressing here? 10 to the power minus 1. If it is of like this, 4, 5. So this position is what now? 10 to the power minus 2. Yes or no? In the school level, you have done it. Yes or? So next, if it is 6, so this position will be got here 10 to the power minus 3 after this decimal point. Before these things are positive exponents here, these are the negative exponents, that too starting from minus 1 there. Now you see here. So it is a 0-digit number. There is no, here it is 10 raised to 0. We won't see for that one here. If it is of 0-digit number, we go with this first, we go with the position of first significant figure after the decimal point here. See, after the decimal point, so the first significant figure is in the position of what here? Is in the position of 10 to the power minus 1. 10 to the power minus 1. So the exponents, the exponent minus 1 itself. 1, okay, let me write like this, right? Right, now you see. So after the decimal point, the first significant figure is in the position of what here? 10 raised to minus 1, right? So I have to look only the first significant figure. So the exponent itself is nothing but what your logarithm value I told in the definition there, right? So with the base 10, of course, common logarithm we are dealing here. So what is the power, students, here? Minus 1. This is the power minus 1 is nothing but what here? Characteristic part of this number here. Characteristic part of this number. 0.1234. Got it? So minus 1 we can't express here. Of course, it is a negative characteristic part you got here. So while writing, you should mention like this, 1 bar. We should not write minus 1. Okay. So why? Because it is a procedure to write in this way only. Okay. Next. Now you see, go for this one here. Second, 0.01234. How do we got this 2 bar? Now you see. Now check it out. So after the decimal point, find out the position of non-zero quantity. So here this is the position in the 0 is in which position, students? After the decimal point, 10 to the power minus 1 position. Here 10 to the power minus 2. Here 10 to the power minus 3. Next 10 to the power minus 4. Next 10 to the power minus 5. But I required what here? The first non-zero, the position of first non-zero quantity. Here is the first non-zero quantity. So its position you see there. Its position is what here? 10 to the power minus 2. So base is 10. I need the exponent only. What is the exponent here? Minus 2. That's why we express 2 bar here. 2 bar. Got it? Minus 2. Instead of writing minus 2, we write 2 bar. Here also you see that. Right? Here also you see. Go for the next one here. This is the main reason. Right? 1, 2, 3, 4. Right? So now this position, after that, it is a 0-digit number. This position will be 10 raised to minus 1. This one will be 10 raised to minus 2. Next, this one will be 10 raised to minus 3. So we should look the non-zero quantity after the decimal point, its position here. So its position will be in the form of like this, 10 to the power minus 3. That to exponent we should take here. That is minus 3. So the characteristic part of this value will be what here? Minus 3. Minus 3 we won't write. We express it as 3 bar. Okay, next go for this one, students. In the same sense, this will be 10 raised to minus 1 form after the decimal point here if they have given 0-digit number, right? So we have, if they have provided 0-digit number only, we have to check in this way here. If they have provided in 0-digit number, then only we have to check in this way, students. So it is in the position of 10 raised to minus 1, next 10 raised to minus 2, next 10 raised to minus 3, minus 4, minus 5, and this one is 10 to the power minus 6 position we have here. So here you are getting the first non-zero quantity here, right? So after the decimal place. So see the position is in this form here, 10 to the power minus 6. So that two exponent we have to take here. That is minus 6 will be the characteristic part. Minus 6 will be the characteristic part. So we won't write minus 6. Instead of minus 6, we write 6 bar here. Got it? How we got the characteristic part of the log value here? Understood here? So in two kinds of log value they'll be asking here. So first kind is what, students? First kind, log of the numbers lying from 1 to, right, infinity. You may get 100 those on there, right? So and another kind is what here? 0 to 1 in this way. So the log of values, log, I have to find the characteristic part of log of this type of this type of values as well as this type of things, 1 to infinity there, right? So if it is the case, if this is the case, means like this, log of the numbers which are zero digit numbers, 0 0.0 0.0 0 point, if they have given means, so what to do? We should write the answer in the form of bar here, minus. So that too, what we should write here? Go for the first non-zero quantity. In which position we have? In the first position. That's why 1 bar. Here you see, it is a zero digit number. See the position of non-zero quantity after the decimal point. After the decimal point, it's a second position, that is 2 bar. Here, non-zero quantity after the decimal point, if it is a zero digit number. Here, 1 is a non-zero quantity. After the decimal point, it's in which position? 1, 2, 3, third position. That's why 3 bar you should mention. Here you see 1. After how many positions it is non-zero quantity now in the zero digit number? 0 point. So after decimal point, 1, 2, 3, 4, 5, 6. Sixth position you have the non-zero quantity. That's why you should mention 6 bar here. Got it? If it is of zero digit numbers. So this is how we find the things, right? So if it is of zero digit number, what you should mention here? Position of, right? First significant figure, significant number, right? That is the characteristic part. We should, that to what here you should mention in the bar here, negative. Got it? So now, if there is no zero digits, if it is not zero digits, they'll be providing like this. If it is of not zero digits, they'll be providing in this way here. Now you see log of 4-digit number. I told you how to find it. It will be in this form here. Log of now you see the numbers, log of the numbers which lies from 1 to infinity. Previously it was lying from 0 to 1. Then means zero digit numbers. Now it is what here? 4-digit number. Here it is 3-digit number. Here it is 3-digit number again. Here it is 2-digit number. So for these things I told you that if it is a 4-digit numbers, 4-digit minus 1, how much? 3. If it is of 3-digit numbers, 3-digit minus 1, how much? 2. 2 will be the characteristic part. If it is of 3-digit number, characteristic part will be 3-digit minus 1, that is 2 digits. Log of 2-digit number, 2-digit minus 1, that is the 1 is the characteristic part. If they have given 0 digits, what to do? You have to go with the position of first significant figure, right? That too you have to mention in the bar here. After the decimal point, first significant figure is in the position of second here, 1 and 2. So 2 bar you should mention that. Got it? So two types of things you will be getting the problems of logarithm to find the characteristic part. Got it? Two types. One is of like this, another is of in this way. Understood now? Understood this, all these things here? So this is what, how to find the characteristic part, students. Characteristic part only here. Right now, let me randomly give you some of the log of the value things, log of a number here. Now check it out. What will be the characteristic part? Right. Randomly, I'll be providing the questions here. Right. Like my light like this here. Now you see, students. Now tell me the characteristic part of this one here. All these three things. Tell me the characteristic part, students. What will be the characteristic parts? Now you see log of how many digit number. Whether it is a 0-digit number, no. No means how many digit number? 3-digit number. 135. If you round off all the things means 3-digit number you will be getting 135. Right? So 135 is a 3-digit numbers. So what I told how to find the characteristic part, 3-digit numbers minus 1 you have to do. If it is of number of digits are k, then characteristic part will be k minus 1 I told you, right? So now, which is non-zero one. Non-zero one means greater than 1 if it is having means. So it's a 3-digit number. The characteristic part will be 2, 3-digit minus 1. Now you see, how many digit number it is? 26 point something there. If you round off and all the things, you'll be getting again a 2-digit number here. 26, you can say that it is a 2-digit number. So it is a 2-digit number means what I told here, if the number of digits are k, then characteristic part will be k minus 1. 2 digits are there means 2 minus 1 will be the 1 here. Plus 1. Plus 1 will be the characteristic part. Now you see here, how many digit number you can say here? No digit. That is 0-digit number you are saying here. 0 point something means it's a 0-digit number here. Right? Got it? So then what to do for this? Right? How to find the characteristic part, students here? I told you if this is the case, there is a separate special procedure to find out the characteristic part. What is the special procedure? The procedure is find out the first non-zero, the position of first non-zero quantity here. So after the decimal point, what is the first non-zero quantity? Whether it is a non-zero quantity, 0 here? No. Here it is a non-zero quantity? No. 7 is a non-zero quantity. The first non-zero quantity here. The first non-zero quantity is 7 here. The first significant figure after the decimal point of the 0-digit. So is what here? 7. So in which position it is here after the decimal point? First position, second position, and third position. In third position it is there. So it is in the third position means the characteristic part will be 3 bar you should mention. 3 bar. Got it now? So let me give one more here. One more. Tell me the thing here. Right? So what happens? 0.0000, right? 0 once again 0, 8, 0, 7, 0. You should not think about the other zeros there. The first significant figure is 7 in this. Here, what is the first significant figure after the decimal point? What will be the non-zero quantity after the decimal point here? First, after the decimal point, you should look the first non-zero quantity. Here, what is the first non-zero quantity? 8. 8 is the first non-zero quantity. See the position of it after the decimal point. After the decimal point, the position of it is 1, 2, 3, 4, 5, 6. Sixth position it is there. So what you should write the characteristic part? 6 bar you should mention. 6 bar. Why you should write 6 bar? I told you that, right? It is in the position of 10 raised to minus 1, minus 2, minus 3, minus 4. Here it is in the position of 10 raised to minus 6. That's why we should write in this way, 6 bar. Instead of writing minus 6, we should write 6 bar there. Got it? I told you the reason, all these things here. So whether you know how to find the characteristic part of logarithm, yes. Now, if you look all these things, you can find out the characteristic parts, friends. So one more is there here. I told you log of any number, right? Or else log of any number here, right? The log of any number, any positive number, right, has the two things here. One integral part. Integral part is characteristic part. I told you that is characteristic part. Now you are familiar to find out the characteristic part. Now there is one more thing after the decimal, log of answers, right? Log of answers. I told you one of the example I gave there, 0.3010, right? So it's a single digit number, single digit number minus 1, 1 minus 1, 0. 0 will be the characteristic part. So then after this one here, after the decimal point, so it is a fractional part or a decimal part, I told you. So this is called as what here? Mantissa. So how to find this Mantissa, students? How to find the Mantissa? So how do we get this Mantissa part? So we obtain Mantissa part with the help of log table, students. There will be we have one of the log table book. You can see this, right? So this is called as log table book, students. Common log table book here. So the Mantissa part can be obtained from this log table, right? So this, how do I find this Mantissa part? So with the help of log table, students, that is in this form. The log table will be in this way here, right? Okay, the log table, it is in, so it has three parts, students. Log table has three parts, right? To find out the Mantissa part of the uh, to find out the Mantissa part, characteristic part and Mantissa part, right? So how to find Mantissa part? Mantissa part can be found from the logarithm. So logarithm table itself, in that book they have given. Or else, if you see the physics textbook and chemistry textbook, in the last pages they have mentioned this log table there. And also, if you have taken the graph things there, right? While dealing in the graph book, in the graph book also, the last cardboard they will be providing the log table. You can go through there also, that, right? Or else you can go for the separate log table book. Okay. So now, how to find Mantissa part? So to find the Mantissa part, we have to go through the log table itself. So in the log table, we have three parts, three main parts, friends. So three main columns, right? Three main columns. So in the first column, it is a blank one here. It starts from 10, right? It starts from 10 students, right? The column, the first column, this is the first column, and this one is the second column. Sorry, up till here. Up till here, it is the second column, right? And this one, it is the third main column. Log table has three columns. This is the first main column, that is a blank one. It starts from 10. It starts from 10 there. Got it? It starts from 10, and where it ends, it ends with 99. It ends with 99. The first main column, it starts from 10 and ends with 99 there. That is the first main column. Second main column, you see, second in this is the second main column. In the second main columns, again you have 10 sub columns. In the second main column, you have 10 sub columns, that is starting from 0, 0, 1, 2, 3, 4, 5, 6, 1 up to 9. So totally there are 10 sub columns here, right? So second column, you have 10 sub columns. Again, in the third main column, you have 9 sub columns. That is called as mean difference column, we say. Mean difference column, we say, right? So that is 1, 2, 3, 4, 5, 6, 7, 8. So 7 up till 9 sub columns you have in the third main column. Got it? So the logarithm table is divided into three main columns. Three main columns, right? So the first main column will start from 10 onwards, that is 2-digit numbers onwards. All are 2 digits. First main columns are what here? First main column has only one column, that is starting with 2-digit numbers, that to 10 onwards, from 10 to 99, 10 to 99, first main column. So whereas in the second main column, students, the second main columns you have 10 sub columns, 10 sub columns here, starting from 0 to 9, all are single digits, 0 to 9. And third main column, that is a mean difference column we say it as mean difference column, starts from what here, 1 to 2. It starts from 1 to 2. You can go through this, you can zoom here, right? It's a third main column. Third main column, we say it as mean difference column, starts from 1 to 1, sorry, from 1 to 9. So this is the second main column. Second main column, this one, 0 to 9. And the first main column, all are 2 digits up till 99 you are getting. Got it? So now, okay, understood this? So, okay, if this is a log table thing here, right? Then what will be the mantissa? How to find mantissa? All these things. Okay, okay, all these things. Let us see here, right? Now you see. Now you see, students, here, logarithm of logarithm. Let me find out this one here. 1, 2, 3, 4. Like logarithm of 1234 value. So what will be the characteristic part? You know the characteristic part. It is a 4-digit number, means 4-digit number minus 1. That is a 3 will be the characteristic part. Then what will be the mantissa part? Then what will be the mantissa part? So mantissa part can be obtained just here. Firstly, in this 1, 2, 3, 4, from the left, what you have to do? You have to make the 2-digit group here. From left to right, first you make the 2-digit number group. Then you take separately the single numbers, right? Then you take the separately single numbers. That is 3 separate and 4 separate. 12 is in the one group, right? 12 is in the one group, 3 is in the another group, 4 is in the some other group there, right? So 3 groups I have to make. 3 groups I have to make. The first group is 2-digit number, second group is single digit, fourth group is also a single digit, right? Of 1, 2, 3, 4. So then this 12 I should look in the log table, students. This 12 I should look in the log table, that too in the first main column, right? That too in the first main column. This is the first main column, students. First main column, this one. This is the first main column. Only one, in the first main column has only one column. So in this I should search what here? I should search 12, right? What I'm dealing here, 1, 2, 3, 4, log of 1, 2, 3, 4, right? This is the one first group I made here. 12 I should search. So this is the 12 students. This is the 12. Then I have to make second group, that is single digit, that is 3 here, right? So I should search. I should search in the second column. In the second column, right? In this is the second column here up till here. So I should search 3. That is third sub column here. 3. The number 3 is here. That is the fourth column will be there, right? In the 10 sub columns. So number 3 you should say. So in the third column. So in the particular 12th row and third column, you should match here. 12th row, third column, you should match the number here, right? You should look the number of the 12th row and third number. What do you get? What do you get? You will be getting 0899, right? If you zoom it out here, 08, sorry, 12th row, 0828 you will be getting 0828, right? Let me zoom in here. You'll be not getting this. If you 12th row, third column, what do you get? 0899 you are getting there. This number, 12th row, third column. After writing 0899 in the rough, then go for the second next number, next single number. 12th row, third column, that is in the second main column. You have to search 12th row, third main column. After finding the number, you should write down separately in the rough. After that, one more is left out. One more group we made as a single number. So this is the 4. This 4 we have to see in the mean difference column. That is in the third main column here. In the third main column, Number 4 we should search here. This is the number 4 now. So in this, the 12th row and the 4 mean difference column here. The 4 mean difference column. What do you get here? 14 you are getting. The number what do you obtain here? You should match here. You should match the 12th row and fourth mean difference column. What do you get? 14. That 14 number you should add to this, which you have matched with 12th row third column. 12th row third column. What you have matched? No, this you have written rough work here, and again you should match with the fourth mean difference of the same 12th row here. So 14 you are getting here. Add it now. Add it. What are you getting here? 13, 10, in what here? 11. Sorry. Add it 9, 0. So 0, 9, 1, 3 you are getting there, right? So the mantis, to get the Mantissa part of this 1, 2, 3, 4, what you got here? 0, 9, 1, 3. So this 0, 9, 1, 3, where you should write 0, 9, 1, 3, where you should express here. So the 4-digit number characteristic part is 3, 0, 9, 1, 3 you got it. Yes or no? The Mantissa part will be 0, 9, 1, 3. So this is how to find the Mantissa part. Okay. So briefly I taught about this one here, how to find the Mantissa part. So once again I'm going to explain this thing here in the next lecture, right? So how to find the Mantissa part, once again I'm going to explain you in the next lecture, students. So until then you go through with the characteristic part, how to find the characteristic part of a logarithm, right? So you go through once there. I'll be explaining the Mantissa part once again in the next class. Thank you. Until then, take care, students.